Welcome back. My name is Michael Kamanga, um, your chemistry from one teacher. I'm back again with the separation of mixtures. So in separation of mixtures, in this lesson, I will take you through the process of sedimentation. Can you remember other methods of separation of mixtures? Any type of a mixture? Yes, there is a decanting, there is a fractional distillation, simple distillation, chromatography, to mention but a few. Mixtures, they're supposed to be separated. So the science behind the separation of mixture is very, very wide because there are so many processes which you can use in the separation of mixtures. However, each process or each method or each technique, uh, it will depend on the nature of the mixture, because the type of a mixture which you have will determine the method which you are supposed to use in separating the components of that mixture. So you don't use like any method like anyhow. No, you need to see the type of a mixture which you're dealing with. So in today's lesson, I'm going to take you through the process of sedimentation. The process of sedimentation. So we have several types of mixtures, okay? But in general, the types of mixtures we have two, homogeneous and heterogeneous. Homogeneous and heterogeneous. Can you give me an example of a homogeneous mixture? Homogeneous mixture? Yes, you can have a mixture of salt and water. Salt will dissolve in water. So salt in this case is your solute, while water is your solvent. If you stir after some time, the salt particles will dissolve and they will remain in the solution. Even if you cannot see them with your eyes, but they're dissolved inside the water, forming salt solution. So this is the homogeneous mixture, because you are unable to tell that this is salt and this is water. So by the end of the day, yes, it is a mixture. So the particles are evenly distributed within the mixture, reaching a point that you cannot be able to see them because they are evenly distributed. So a mixture of a liquid and an insoluble solid is a type of a heterogeneous mixture in which the solid does not dissolve in the liquid. So the solid does not dissolve in the liquid. So this results in the solid particles being dispersed throughout the liquid, but not uniformly. Yes, the solid particles will be dispersed throughout the liquid. However, this is not uniform. No wonder it is a heterogeneous mixture, because you can able to tell that this is the liquid and this is the solid, even if they are mixtures. So please take note of that. Only characteristics of such kind of a mixture, we have the appearance, we have the separation as well. So for the appearance, the mixture often appears cloudy or murky due to the presence of solid particles suspended in the liquid. So the solid particles will always be in the liquid. They will be suspended because they don't dissolve in the liquid. So you can be able to tell that this is the solid and this is the liquid. No wonder on the appearance, it will be cloudy. Then separation, that is over time, the solid particles may settle at the bottom due to gravity, forming a sediment. This process is called sedimentation. So the process is called sedimentation, where the separation after some time, the solid particles may settle at the bottom due to gravity, forming a sediment, and this process is called sedimentation. Then filtration. The solid particles can typically be separated from the liquid using filtration or decantation. Okay, so we're using filtration or decantation. And on the examples, we have sand and water. So an example of a heterogeneous mixture, we are talking much of heterogeneous here because sedimentation is used to separate a heterogeneous mixture. You cannot use sedimentation to separate a homogeneous mixture, no ways. So sand and water is an example of this heterogeneous mixture. When sand is mixed with water, the sand particles do not dissolve and can be seen suspended into the liquid. Over time, the sand will settle at the bottom. So as you can see, here we have a mixture of salt, water, and sand. So sand particles will be at the bottom because the sand particles are denser than the water particles. Then we have chalk and water. So chalk powder mixed with water results in a suspension where the chalk particles do not dissolve. So we have water and chalk particles. Once mixed, as you can see, they're forming a cloud because one of the characteristics is that the appearance is cloudy. As you can see there, it is indeed cloudy. Then we also have a mixture of flour and water. So mixing flour with water creates a suspension that appears cloudy with flour particles dispersed throughout. So as you can see here, we have flour and water. As you can see, the flour is settling down there after some time. So if you mix flour with water, it creates a suspension that appears cloudy with flour particles dispersed throughout. Now, in scientific terms, such mixtures are referred to as suspensions. Yes, they're suspensions and can be separated using several methods. You talk of settling, decantation, or filtration. So in general, the type of mixtures, they are referred to as the suspensions. Even if they are suspensions, we can also separate them using several physical methods. You can use settling if you wish. You can use decantation or filtration. What about sedimentation? So sedimentation as a process of separation of mixtures, it is based on the density difference between the components of the mixture, typically involving a liquid and an insoluble solid. You see now, we are specifying the kind of a mixture which can be separated using the physical method of sedimentation. So here what we are saying is we can use uh, liquid, we can separate a mixture of a liquid and an insoluble solid. So we are using a liquid and insoluble solid. It should be a solid, yes, but the solid should be insoluble. So a mixture of a liquid and insoluble solid. And this is just a natural and straightforward method that relies on gravity to settle solid particles out of a suspension. So yes, after some time, you allow settling. You leave the mixture to settle. So once you allow it to settle, you'll be able to see that the solid particles will settle down due to gravity and possibly because of issues to do with density. So they are denser than the liquid. That is why they will settle at the bottom of the container. Now, let us see describe sedimentation. So we should look at the description of sedimentation as the process. So sedimentation is used to separate solid particles from a liquid. What type of solid particles? The solid particles which are insoluble in a given liquid, allowing the solids to settle at the bottom of a container due to gravity. At the bottom of a container due to gravity. So you allow the solid to settle. And what is the process? The process starts with mixing. So I want to take you through the process of sedimentation. How is it done? So the first thing to do is mixing. So the mixture is allowed to stand undisturbed in a container. It is allowed to stand undisturbed in a container. Settling. Over time, the denser solid particles settle at the bottom of the container, forming a layer of sediment. Forming a layer of sediment. Then we have decanting or removal. So once the solids have settled, the clear liquid that is supernatant can be carefully poured off or siphoned away, leaving the sediment behind. This is very, very important. As you can see, decanting is not sedimentation, but the two processes, they go hand in hand. So you cannot do sedimentation without doing decanting. So they're more or like the same, but necessarily they're not the same. So you just allow with time the denser solid particles to settle. And why is the denser solid settling? It is because of gravity and density as well. So they will form a layer of a sediment at the bottom of the container. Then from there, what do you do next? You remove or you decant. So once the solids have settled, the clear liquid and can be carefully poured off or siphoned away, leaving the sediment behind. So you cannot do sedimentation without settling because you are allowing the mixture to settle so that sediments must be formed. So once the sediments have been formed, you use decanting or removal. Now, what are the tools used? So you will need a settling tank or a container or a beaker. So here I have an image of a beaker, which is a vessel where the mixture is allowed to stand. A vessel where the mixture is allowed to stand. So the tools used. You need a decanter, which is an equipment used to remove the clear liquid without disturbing the sediment. So you are supposed to remove the clear liquid without disturbing the sediment. So use a decanter. And in general, uh, the overall process of sedimentation. Can you describe it? The overall process of sedimentation. Can you describe it? Yes. Type something in the comment section. Can you describe it? Good. There must be settling. There must be mixing. Yes. Mixing, settling, then removal or decanting. And why are you allowing settling? Why are you allowing settling? Yes, because you want the sediments to be formed below the container. That is why the process of settling is very, very important. So quickly, let us look at examples of sedimentation. We have sand and water, wastewater treatment, clay and water. Sand and water, wastewater treatment, clay and water. So in sand and water, when sand is mixed with water, sand, an insoluble solid, mixes with water. So the sand particles, obviously, they are denser, then they will eventually settle to the bottom. Then we have wastewater treatment. In sewage treatment plants, sedimentation tanks are used to remove suspended solids from wastewater. Then we have clay and water. So in the mining industry, sedimentation is used to separate fine clay particles from water. In the mining industry, sedimentation is used to separate fine clay particles from water. So the examples of sedimentation, yes, you can use sand and water, you can use for wastewater treatment, and again in clay and water. Clay and water. So now allow me to take you through a video which is just giving a general overview of the process of sedimentation. So this video will simply be illustrating the process of sedimentation. So let us appreciate the video and observe what is happening there. Because if you observe, you understand it better. So let us see what is happening there.
Welcome students to my channel ANG Classes. Today I am going to perform activity based on sedimentation.
So here, of course, we are talking of sedimentation, decantation, and filtration. So we are much interested in sedimentation because we already covered decantation and filtration.
Decantation and filtration. So, material required for this activity are 3 transparent glasses. We will label them as A, B and C. A glass, we will half fill it with water. We need soil, spoon, filter paper and funnel. So, let's start this activity. First, we will add 2 spoonfuls of soil to our glass A.
So remember the soil, yes, it is an insoluble solid, while water is our liquid. Remember in sedimentation, we are using a liquid and an insoluble solid. So in the container A, there was water and they are adding soil. So observe what is happening there.
We will mix it and we will keep aside without disturbing for 10 minutes.
Yeah, so they are waiting for 10 minutes because remember in sedimentation as a process, they settling. So they want settling to occur, sediments to be formed, which will be below the container due to gravity. So that's why there we have to wait for 10 minutes for sediments to form.
Students, you can see.
So after 10 minutes, you see what is happening. Remember, on the appearance of suspensions, we said they are cloudy. As you can see, this is cloudy. So after 10 minutes, there is a formation of sediments. The sediments settle down the container because of gravity. So after 10 minutes, that is what has happened. The sediments have been formed.
The soil has settled down. So you know when heavier component.
So in general, sedimentation is the process of settling down of heavier particles in a suspension when left undisturbed. That is a general definition of sedimentation. The process of settling down. That is why settling is very, very important in sedimentation. So the process of settling down of heavier particles in a suspension when left undisturbed.
In a mixture settles down. As you can see, soil is heavier, so this process is called sedimentation. You can see here the soil has settled down. Now we will pour water.
So after settling down, remember the next process is, do you remember it? After settling, then what comes next? Yes, it is decanting or removal. No wonder here, after the sediments have been formed, it was left for 10 minutes for sediments to settle. Then we have to remove. So this is removal.
From glass A to glass B without disturbing the sediments. Okay, we will not disturb sediments and we will pour water to glass B. Now you can see.
So what do we have there? This is the water. We have water, and this the soil particles. And what we are doing is the decantation, which is the process of passing a liquid from one container to other without disturbing the sediments. So what is remaining in the cup A is the sediments, that is the soil particles, and here we have water particles. The water particles here, the water is not looking clean because some small particles of the soil, they have managed to dissolve inside. That is why the water is not looking clean.
So this removal of water, removal of water above the sediment, this process is called decantation. Okay, so this process is called decantation. Now we will pass this decanted water to filter paper. You know that filter paper, I just make simple cone of that filter paper and we will put this.
So what they're doing now? They want to filter the water. Remember filtration, because some soil particles, they are inside. They are mixed. The water particles have mixed with the soil particles. So here they want to filter using a filter paper.
Water to glass. Now see what happens. You can see in this filter paper fine impurities, they are settled.
So in filtration, this is just a process of separating suspended solid matter from a liquid by passing it through a filter paper. Now, if you are to compare the water particles in B and C, can you see that water in C is much clearer and cleaner than the water in B? So from here to here, it was decanting. From here to here, it was filtration. I hope you have understood what is sedimentation and the decanting and filtration. So let us proceed. Now, we have factors which affect sedimentation. Yes, on factors affecting sedimentation, we have particle size, density difference, viscosity, and temperature as well. So particle size, larger and heavier particles settle more quickly than smaller ones. So in settling, if the particles are small, it takes a lot of time. Then you have density difference. That is a greater density difference between the solid and liquid leads to faster settling. Then we have viscosity. That is, high viscosity of the liquid can slow down the sedimentation process as well. Temperature, that is, the higher the temperature, higher temperatures can decrease viscosity and promote faster settling. So indeed, these are the factors which affect sedimentation. So what are the advantages of sedimentation? Only the advantages. Sedimentation, it is also simpler. So simplicity is the first advantage of sedimentation. So it is a straightforward and natural process that doesn't require complex equipment. It doesn't require complex equipment. It is also cost effective. So no expensive materials or machinery are needed. Environmental friendliness. It is a non-chemical method, making it environmentally benign. So indeed, it is environmental friendly, it is cost effective, and it is simpler as compared to other methods. Now, let us look at the applications of sedimentation. Yes, sedimentation is a very, very important physical method of separation of mixtures. So sedimentation can be used in water treatment. It is used to clarify water by removing suspended solids in water treatment plants. So we can use sedimentation in waste or water treatment. Water treatment, this is done in the water board. They use the same sedimentation, which is very, very important. It is also used in mining and mineral processing. So it helps in the concentration of ore by removing unwanted particles. It can also be used in food and beverage industry, that is used in the clarification of juices and wines. It is used in the clarification of juices and wines. Okay, so having looked at the overall process of sedimentation, we have defined what sedimentation is. We have looked at the general description of sedimentation and the general process of sedimentation. You talk of mixing, settling, and removal. We have also looked at examples of sedimentation, and we have also looked at a video which is illustrating sedimentation. So having discussed all that, there is an activity here. So the questions are just a reflection on the lesson. So here, always feel free to provide your answers in the comment section and compare with my answers which are provided in the comment section. So you will find the answers there and compare with your answers. Remember, my answers are not limited. It doesn't mean that they are the only answers. No, they are just suggested answers. So please, you can add extra information which is relevant, and you can also ask a lot of questions using the comment section. So the first question is, what is sedimentation used for? How does sedimentation differ from decantation? And what are the advantages of sedimentation? What are the limitations of sedimentation? Can sedimentation be used in separating two liquids? And what factors affect the rate of the sedimentation? Okay, so as usual, you can also give us feedback through the WhatsApp number, which is always provided to you in other lessons. You can also visit us at website. We have our website, Xulendo, so always feel free to give us the feedback. For today's lesson, the following are the references which I've used. So we have Excel and Succeed, Junior Chemistry Book 1, Achievers in Chemistry Book 1, Django Chemistry Book 1, Samuel Kalea Chemistry Book 1. For illustrations, design, and graphics, they were done by Charlotte Bruning and Dave Mumba on work Xulendo. While for the photos and the video, you have the links there, so feel free to visit at any time. Well, until we meet again in the next lesson, bye.